Hello everybody, I am Dr. Muhammad Hayat Razvi, professor in ECE department. In this lecture, I would like to give you the introduction about low power VLSI circuits and systems. This subject completely aims at power reduction of mass circuits. So, the syllabus given by the university is like this. Unit 1 is all about introduction and the mass structure, that is, it gives you a clear explanation and demonstration of how a mass device operates and how it behaves and what are its electrical properties. Coming to unit 2, it is mass inverters, the different switching activities are discussed in this chapter 2, its characteristics, inverter characteristics, and its driving parameters, all that you have studied in VLSI design is covered in this chapter, chapter 2. Chapter 3 is sources of power dissipation. When you understand the mass structure and its behavior in unit 1 and in unit 2, and the mass designing the circuits using the mass inverters and other combinations of the mass circuit, you will come to know what are the sources of power dissipation. After understanding the sources of power dissipation, we will now attempt to have minimizing the switching capacitance. Switching capacitance always incurs power dissipation. So, if you minimize the switching capacitance successfully, you can easily reduce the power consumption. The final chapter will be minimizing the leakage power. Minimizing the leakage power is it gives you various methods of minimizing the power dissipation, what can be done, what are the steps to be taken. All this is covered in this minimizing the power dissipation. These are the textbooks. The textbook, which is very much useful and very much large content of the syllabus, has been covered by this textbook. First one, which is Ajit Pal, entitled Low Power VLSI Circuits and Systems, published by Springer. So, let us now jump into the subject. The first transistor was made by vacuum tubes. You might be aware that vacuum tubes are very bulky in size. These vacuum tubes normally have the size of your thumb, more than the size of your thumb. It is this much of bulky and it consumes very high power. When I was a kid, that is before 30 years almost, there were radios which were made of vacuum tubes. These vacuum tube radios were not turning on immediately. These radios used to take a little time of around 40 to 50 seconds, nearly around 1 minute. Then it slowly starts working. The reason behind is these vacuum tubes need to get heated up. They'll have filaments, they'll have cathodes. These filaments have to get adequate heat to liberate electrons from the cathodes. Now, the liberated electrons from the cathodes have to travel to the other electrode to make the device functional. So, vacuum tubes were very bulky, and obviously, whenever you speak about filament and heating up, what happens? the ambient temperature of the circuit is very high, it consumes large power. As we have discussed, the size of the vacuum tube is of your thumb size, more than the thumb size, so it obviously will occupy large space. So these are the problems with the vacuum tube era of electronics. All the devices which were using vacuum tubes as diode, triode, tetrode, pentode, all these were suffering with all these issues like bulk size, high power consumption, and more area. PCBs of that time were very large. The radio which I have seen in my childhood is of the size of not less than the size of your more than the size of your CPU, desktop CPU. So it is very bulky. After a little gap with large investigation, people have introduced transistors. Transistor was invented by William Shockley, John Barden, and Walter Brattain in Bell Laboratories in the year 1947. After the invention of these transistors, lot of changes that have been taken place in the electronics industry, which which will be discussed in the subsections of this lecture. Now, the advantages of these transistors, all of you might have seen, the size of the transistor will not be more than the head of your pencil, and it will be very little. So, size is very smaller, and it obviously consumes very less power, and it is very quicker. It was not regular BJT transistors were very fast. They are not slow as we have discussed about vacuum tubes. So, and these devices, vacuum tubes, used to have filaments, cathode, all were standing over some copper base rods. Now, those devices were not reliable. They may get damaged with vibration, sudden shocks, and all. Now, these transistors, which were invented in 1947 by Bell Laboratories, are solid-state transistors. They don't have all these issues. They don't have large size. They don't consume much power, and they don't occupy large space, and they are not weak. Mechanical vibrations cannot harm them. So these are the advantages of transistors. The scientist whose name is Gordon Moore, a member of Schottky team, founded Fairchild and Intel fabrication units. These two are the very familiar IC fabrication units around the world. So these were established or founded by Gordon Moore, who is a scientist in microelectronics. The company Fairchild developed the first planar transistor in late 1950s, which was the key development of the integrated circuits. After the invention of solid-state transistors, many changes have took place, like evolution of integrated circuits and different sizes of different quantity of transistors that are accommodated on a die, silicon die, have decided the applications of integrated circuits in various fields of electronics. The planar technology allowed realization of the complete electronic circuits having number of devices and interconnecting them on a single silicon wafer. As we all are aware, we have studied in VLSI, a number of transistors can be interconnected over a single chip of silicon to realize a particular function is possible, which is called as IC. This has become possible because of the introduction of the planar technology. Now, the scientist, technologist Gordon Moore, who have predicted the advancements that will be taken up by the electronic fabrication technology year by year, will increase the number of transistors that can be accommodated over a chip. He has predicted from 1950 to 1975 and published a paper in IEEE International Electronic Devices meeting, which was giving you a prediction of number of devices per chip every year. These are the improvements, step by step, year by year improvements he has predicted and gave in a graph. And in the very first prediction, he has predicted that number of devices in a chip will double every 2 years. See, he also predicted that component density in an IC will double every year. The component density will double in every 18 months. So he has predicted that with the technology, as the technology advances day by day, the fabrication units will acquire the capacity of producing double the number of transistors that today's technology is having. By within they can double within a period of 18 months. Then the electronic IEEE conference has requested Gordon Murray to predict once again, give a little brief for about next 30 years. Then Gordon Murray has extended his prediction till 2010, which will be shown in the coming presentation slide. Just have a look on that. This has set a benchmark to the electronics world, that how many number of transistors that can be accommodated, that are the fabrication units have to reach to how many number of transistors every year has been demonstrated by this Moore's law. This has become a law. As you can see, the first transistor 4004, first microprocessor 4004, 8008, 8080. These are the very familiar microprocessors that are there, produced by Intel and other companies, are having. This is the transistor count. Y-axis is representing the transistor count and x-axis is representing the year. Now these are the devices that have been developed by various factories, which are meeting, which are almost very close to the discussed Moore's law. So that is called Moore's law. If you see the evolution of IC technology in this slide, in the year 1947, the first transistor was invented. In that time, the silicon wafer or the substrate was occupied by single transistor. So with that technology, you can produce junction transistors and diodes on the silicon wafers. In the preceding 1950s to 60, in the preceding decade, the discrete components have been introduced on the silicon chip, which can accommodate planar devices, logic gates, and flip-flop into the chip, which is a great advancement. After 1960, consider till 65, the evolution of small-scale integrated SSI chips were developed, where 10 to 100 devices can be accommodated, which will help you to have counters, multiplexers, decoders, and adders. After 1965, it is next 5 years. In the next 5 years, medium-scale integrated circuits have been developed, which can accommodate, which have the capacity of accommodating till 1000 devices, which will help you, which is sufficiently considered as can be produced. 8-bit microprocessors, ROMs can be produced with 1000 gates per chip. From 1971 to 79, that is almost around a decade time, In a decade time, the industries has acquired the technologies which can comfortably produce DSPs, digital signal processing processors, RISC processors, with a bit rate of bit length of 16 to 32 bits microprocessors. So this was a very good step that industries took. After this era, the world which we are seeing, having palm tops, gadgets, PDAs, many devices, thin laptops, portable, movable devices, whatever the latest advancements of the technology that we see today have been developed in the time 1980 to 85, which were called as VLSI chips. These chips can accommodate till 20,000 to 50,000 devices, the components on a chip, which are sufficient with this technology can comfortably produce 8-bit processors, 16-bit processors, and 32-bit processors as well. After 1985, VLSI has taken many advancements, many fabrication techniques. So many of the researchers have given their time in refining the technologies that were available till 1985 to see the advancement, to witness the advancement of ULSI chips. ULSI stands for ultra large scale integration. ULSI chips are ultra large scale integrated chips. We can have further more discussion in our coming lecture. Thanks for watching. Thank you.